Hello everyone, I'm Aydin Tabrizi. So I'm going to talk about a case study evaluation of renewable energy strategies using building information modeling and energy simulation. This case study was conducted in collaboration with my advisor, Dr. Paolo Sangonetti at the University of Kansas. First, I would like to talk about the energy consumption in the building and the importance of this issue. Basically, the residential and commercial buildings consume almost 20% to 40% of energy use. And in the US itself, in the developed countries, of course, and in the US itself, this number for this type of buildings is almost 40%, and they're responsible for 40% of global CO2 emission, which this number exceeds the other two important factors, which are transportation and industrial. Therefore, the energy efficiency is a prime objective due to the population growth, demand for building services, comfort level, and the amount of the time which is spent inside the building. LEED in connection to energy analysis. LEED stands for Leadership in Energy and Environmental Design, and it is a standard developed by United States Green Building Council. So basically, as you see on the left-hand pie chart, the LEED has 110 total points, and it has 8 segments. Basically, the energy has the largest amount of points under the LEED criteria, which is 19 points. And then if we based on as you see in the second pie chart, if we add up the other energy-related criteria in the other sectors, we can add up the LEED energy-related section to 41 points, which you can see in the right-hand pie chart, where we have 90 points from the energy itself, and then we can add up to 7 points from renewable energy, 3 points from green power, 5 points from measurement and verification, 1 point extra from daylight, and one other point from wastewater treatment. So in general, we can add up 41 points, which is a large number out of the 110 points of the total LEED points. And this shows the importance of energy modeling in relation to the LEED analysis. BIM in relation to LEED and energy analysis. Building information modeling helps the AEC industry to, of course, visualize and collaborate. And then it's much more easier for the AEC industry to see the problems ahead of time during the design and construction. And also it can support the study of the alternatives more easily, and by the development of this virtual environmental tab. So we can now at the moment synchronize the LEED online and virtual environment tab. And in the real time, you can see how many points you can get based on the LEED criteria. And also you have the real-time access to your own project when you have any change in the energy segment or any other sector. And also, of course, linking the BIM to energy analysis tool allows for the evaluation of energy use during the operation phase. So the research objectives for this project, basically we decided to find out about the discontinuities of the renewable energy, which is the main specific focus of this project, is the PV panels degradation and LEED credit. Also to evaluate the alternative renewable energy scenarios, and then recommendation for the optimization of building performance with the potential to get net zero energy building. For this study, we considered the Center for Design Research. This building is located in the University of Kansas in Lawrence. Basically, as you see in the pictures, there's different sustainable features in this building, such as green roof, or the wind turbine adjacent to the building, or the glazing to control the glare and also to control the solar heat during different seasons. And also there are other features inside the building, such as green wall or the electrical charger for the vehicles. This building received the LEED Platinum this year, start of this year, and of course LEED Platinum is the highest LEED criteria that a building can get with the LEED certification standard. So basically, since our focus in this project was to find out about the renewable energy and specifically the PV panels, so we wanted just to see how the PV panels on the roof performing over time. So we did some literature review, and we find out that there is some research about the PV panel degradation, and one of them is the research by National Renewable Energy Laboratory based in Denver, Colorado. So they have done some research on 2,000 panels, and based on the research, there is a 0.8% of degradation rate each year for the PV panels. And as you can see here, there is a change on the surface and the quality of the PV panels. So, and it affects the amount of the solar heat can be absorbed by the PV panels, and basically it affects on the electricity generation by these PV panels. So then the two key drivers in the performance of renewable energy, as I mentioned. So first of all is the efficiency of sunlight conversion into power, and also how this relationship changes over time, which is defined as the degradation rate of these panels. And of course, the degradation rate of the PV panels is important financially, because the higher degradation equals to less power generation, and also in the same time, the lower future cash flow. The methodology for this project, first we got the data about the energy consumption from the building, and also the amount of the energy are generated by this building by the renewables. These are the real data from the building at the moment. And then we developed a model, we did a simulation model by Revit to find out about the building consumption and generation. Then we evaluated different scenarios to test parametric variation of the renewable systems and also building operation schedule. And finally, we analyzed the results to give the recommendation about the optimization of the building performance with the potential to change it to the net zero energy building. So in this graph, basically, you can see the process that we developed, as I mentioned. So data collection and the CDR model in the Revit. And then the Energy Plus was used in collaboration with the Revit to analyze, and the base case and current performance of the building were achieved from the data from Facility Manager. And then the results compared, and 3 retrofit plans were allocated as different scenarios for this project. Basically, for the energy analysis procedure, first we developed the model in the Revit architecture, and then the model was, after specifying the different volumes and zones in the building, it just exported as a GBXML file to Green Building Studio, and then to Ecotect. And in Ecotect, we get the weather data and also the operation schedule. And after that, the Ecotect file was exported as an input data file to the IDF Energy Plus. And then the IDF editor of Energy Plus was used as to define the geometry and also to application of the retrofit plans to this model. Here in these two tables, you can see the process we used for our retrofit plan. So basically, the top table shows the retrofit plan for the PV panels. The first row shows the base case, which is the building in the design phase, where we have this amount of PV panels on the roof, and we don't have any degradation rate for our panels. The second row shows the current building performance, where we have the same amount, but the degradation rate of the PV panels has happened, so we don't have the initial efficiency. And then we have the 3 retrofit plans, where we have, in the first retrofit plan, we have kept the PV panels in the same number, but we replaced the degraded PV panels to the new ones. In the second retrofit plan, we increased double the number of the PV panels with the change of the initial efficiency. And also in the retrofit 3, we doubled the PV panels, but we decided to put half of the PV panels on the facade, on the south facade, and the other half on the roof, with the replacement of the panels to the initial efficiency. And also in the second table, the lower table, you can see the schedule for the operation of the lighting and also for the HVAC and equipment operation, where basically this is the building is educational facility building. And then we noticed that even though this building has been considered to perform from 5 a.m. to midnight and also for the weekdays, but in reality we don't use this building during the weekdays and during the weekends, and also it just used during the routine office hours, which is 8 to 5 p.m. So basically we just changed our retrofit plans for the equipment schedule from 8 to 5, and there is no use of the building during the weekends. So here you can see the site and source energy use intensity, and the electrical load that we got, I mean, obviously from our base case and current performance, because first we wanted just to see how the building performs now after 2 years of the performance in its current situation. So, I mean, our source energy has been basically increased from the base case to current performance, obviously, and then electrical load generation by the PV panels has been decreased from base case to current building performance. But for the energy use intensity for our equipments, basically for our lighting and HVAC, it has been no change since the current performance and base case works non-stop and for weekends and weekdays. So for our results, since we wanted to consider to evaluate what's the generation and what's the consumption, basically we noticed that like the PV panel energy generated by the PV panels has been decreased from base case to current building performance. But when we introduced our retrofit plan from retrofit 1 to retrofit 3, so there is a slight change in the retrofit 1. But like from retrofit 1 to retrofit 3 and 2 and 3 respectively, we have dramatic change when we increase the number of PV panels and we replace the efficiency of the panels. And in the same time, our energy use summary shows that the consumption has been had the opposite trend. So it has been increased from base case to current building performance. But with the introduction of this retrofit plan, we can reduce our energy consumption from retrofit 1 to retrofit 3, where retrofit 2 and 3 has the has the lowest consumption in comparison to the current building performance. And also about the carbon equivalent and CO2 emission. So basically we have the same trend. So we have the carbon, the amount of carbon produced, it is increased from the base case scenario to current building performance. And then the number has been decreased again from the current building performance to the retrofit 1 and retrofit 2 and 3 respectively. And also the CO2 emission has had the same trend when it increased, and then it has the reduction for the current building performance to retrofit 1, 2 and 3. So basically we decided to find out how much the cost could be saved with these plans, and also how we can create the incentives in the owners and facility managers to consider these options, because basically, I mean, when they see that they have the PV panels, so maybe they won't be that much interested to consider the changing option or increasing the number. So we evaluated retrofit 2 and retrofit 3 as our best scenarios, and then we noticed that for these two cases we would have $1.31 and $1.42 per square foot saving. And also the amount of the total cost for this PV panels addition to the building and the replacement would be almost $10,000 for this facility because of the roof size. So basically we noticed that the payoff period would be 3.5 years, and it could be a possible solution for the people to consider this option, because it could be a not that much, it will be a short time period for them to pay it off for the amount of the investment that they make at the first point. So in our discussion, actually we evaluated the LEED criteria, and as I said in the second slide, we have just 7 points for the renewable energy under LEED. And basically when we have 13% of renewable energy, like it's wind or solar or any type of renewable energy, so we can get that 7 points under LEED criteria. And we noticed that this is kind of not giving any incentives to the people to consider to improve or to increase or to replace. And in order for people to consider this renewable energy consideration, there should be more incentives for them to, under the LEED certification, where they can see they can get higher grades for that and higher points under the LEED renewable. So this is a important issue that needs to be considered and discussed under the LEED certification for the future upgrade of the versions. So basically the future direction would be, as I said, the consideration of the LEED, and also to see how much the renewable energy points can be improved or increased in the LEED current version. So probably the upgrade of the LEED version in the newer version, which is coming out this year. So basically of course, they can, have consideration of the renewable energy enhancement in that. Also, the other issue we had, it was the interoperability between the BIM and the energy analysis. So when we were transferring the model from Revit to, final to Energy Plus, so before that, in the Ecotech, when we had the model from Revit to Ecotech, so basically we were losing some of the thermal properties of our materials, and then this interoperability needs to be considered in the newer version of the Revit, or in the newer version of the BIM modeling between the Energy Plus and BIM evaluation. And the conclusion is, as I mentioned, so it was a case study we considered, and it was the 3 retrofit plans, and we had those interesting results, and we had a return of investments of 3.5. Thank you.
Are there any questions from the floor?
Yes.
I'm always interested when I come across studies like this about whether the learnings from it are proliferating. Is anything being done to make changes to LEED on the lines that you're proposing?
Actually, the current version, they have done the update. It was supposed to come out last year, but then it was delayed for this year. So it is coming out probably, I guess, by end of this year, so the new version. And then in the new version, no, unfortunately for the renewable, it's still the same points. They haven't done any change about the points for the criteria for renewable energy, but they are improving the versions, they hadn't done it since 2009, so this version would be the newest version from the 2009. But in the future versions, probably they will consider this factor, because it needs to be considered more seriously, the renewable energy option.
Is there anything being done on the design of PV panels to improve or reduce the degradation of performance? 1% per annum.
Right.
It's supposed to last 25 years.
Right. Exactly. Actually, no, that is my research that I am working on that at the moment. So basically, based on the literature review that I had, so now they know about this problem. So there have been some development of the new PV panels recently in Germany. So they have considered this factor, how they can improve the life cycle of the PV panels more, during the time. But still, there is some research and literature on that, but there haven't been done any, change, for example, to, yeah, sure.
It appeared, did you consider evaluating the assumptions that were made in the original LEED submission? As opposed, so it seems to me you've created a new theoretical model of the building. And what might have been more interesting would be to have looked at the original assumptions compared to what the current condition is, and then the renovations. Because many the reason LEEDs changed so much is because particularly the gold and platinum buildings have so underperformed on energy.
Right.
That actually many times they cost more than a non-rated building.
Exactly.
And so what seems to be a little bit missing is that connection to the beginning.
Actually, we consider, I had the base case. So, we have the base case, which is the documents that they used in order to get the LEED criteria, LEED certification based on that. And then I had the current building performance for now, and then I had introduced that to retrofit plans in order to, as a new options for the consideration.